This video, we're going to graph some sine functions using transformations. I'm going to be using the Desmos graphing calculator over here to help you see some things. We could also use our TI-84s for this, but it's just easier to click on the points and show you the ordered pairs here on Desmos than to try and find all of them by hand on the TI-84. So let's go ahead and look at this first one, y equals 5 sine of x. The characteristic points for sine are given here in red under y1. The first period is from 0 to 2 pi. You notice its domain is all real numbers. It's going to go everywhere from left to right. Its range is from -1 to 1. Its period, or one cycle of it that we look at, starts at 0. And then at pi over 2, it has a maximum of 1. At pi, it has a 0 again. At 3 pi over 2, it has a minimum at -1. And at 2 pi, it has a 0 again, and it starts the cycle all over again. We've typed in y equals 5 sine x into y2, our green function here. And you can see that I used this table to show you those same characteristic points, that the zeros are the same, but the maximum is now at 5 and the minimum is now at -5. The same x values here, that this is still where the maximum and minimum occur, but it's now 5 times the amplitude, because the amplitude is equal to the absolute value of what we call A, where this is written as y equals A sine of omega x. We'll get to that a little bit more in the next video or two when we graph sinusoidal functions. But right now we're just going to do this with transformations. And the transformation that we see here is a vertical stretch. So we see that we have 0, 0, then pi over 2, 5, pi 0, 3 pi over 2, -5, 2 pi 0, and we can keep graphing as well if we wanted to graph more cycles. Let's use everything that was given to us. So we're going to go back up here to a maximum, then back down here. We're going to get a curve that is a wave like this. Again, it looks much better on Desmos over here. So now what happens when I add or subtract something on the inside? Well, that's going to be something called a phase shift later when we talk about it, but it's just a horizontal shift. So we're going to take those points that we had and we're going to move them pi to the left. So 0, 0 gets moved over to pi. We still have pi over 2 later. We have our maximum, and it's still at 1 because we haven't stretched the graph at all. Then we have a 0 at 0, 0. Then we have a minimum at pi over 2. And we just follow the same pattern like so. And our graph is going to be a wave that looks like that. Now, if we shift the whole graph down 5, then we start at 0, -5. We go to our maximum, and it's going to be 1 above that at pi over 2, -4. Then we come back to equilibrium at -5 at pi. Then our minimum is going to be at 3 pi over 2, -6. And we repeat that cycle over and over again. And we get a graph that has a line of equilibrium at y equals -5. Doing my best here to draw that wave. Again, calculators are way better at graphing waves than I'm by hand, but there it is. Now we have a reflection as well as a stretch. So we're going to have 0 times -2 is still 0. Instead of a maximum at 1, we now have a minimum at -2 at pi over 2. Then we have another 0. Then we have a maximum at pi over 2. And we follow this pattern. We get this wave like so. Now we have a compression in the horizontal direction, and this is going to change our period and our frequency. But just remember that it happens pi times faster. So if I had control over this, I would change my scale so that it would not be in terms of pi. This one's going to be challenging because we're getting rid of the pi. So let's try it though. Pi times 0 is still 0 here. Now at 1, which is somewhere right in here, that's a third of the way to pi, I have my maximum. And then at 2, which is somewhere right around there, I have a 0. And then at 3, which is right here, right before pi, I have a minimum, and then so on and so forth. And it's going to repeat every 1. So let me show you what that looks like on Desmos because it's actually much easier to graph on here. If I make this sine of pi x, I'm going to turn this one off. I'm going to change my settings over here on my x-axis to step by 1s and to go from -3 to 3, let's say. And you're going to see that the new characteristic points are at 0, 0, 1/2, 1, 1, 0, negative 1.5, -1, 2, 0, and so on. So very hard to actually graph that in terms of pi, but let me change this so that you can see what that would look like. If I go from -pi to 3 pi and go in steps of pi over 2, then you can see where this would be. Like I was saying, it's really hard to graph that exactly, but you're getting something like so. It's like that, and then down here, then not quite at pi over 2, and so on and so forth. The other side here, 0, then up and so on. So not quite at pi. It's happening 3 times as fast. That's what I want you to see. Very quickly. All right. Let's go down to number 6. We only have a couple more for this video, so we're going to put 2 things together. We're going to stretch vertically and we're going to shift vertically. So let's make a table of our characteristic points here. 0, pi over 2, pi, 3 pi over 2, 2 pi, and then 0 plus 3 is 3, 1 plus 3 is 4, 0 plus 3 is 3. Negative 1 plus 3 is 2. 0 plus 3 is 3. Let's see. Nope. Hang on. 1 times 2 plus 3 is 5. Negative 1 times 2 is negative 2 plus 3 is 1. There we go. So 0, 3, pi over 2, 5, pi, 3, 3 pi over 2, 1, 2 pi, 3, and the cycle is going to keep repeating like that. So it looks like so. Let's use those characteristic points again to help us here. That our original x's were at 0, pi over 2, pi, 3 pi over 2, and 2 pi. We're going to shift everything pi over 3 to the left. So pi over 3 is a negative 2 pi over 6. 2 pi over 3. This is 9 to 7 pi over 6. And this is going to be 5 pi over 3. All right, so there's my new x's. I'm going to put in there. And this was my 0. This is my maximum, or my minimum now, negative 3, 0, 3, and 0. So negative pi over 3 is around here. Then at pi over 6, which is about here, I'm at negative 3. Then at 2 pi over 3, I'm at 0 again. And then at 7 pi over 6, I'm at 3 again. And then at 5 pi over 3, I'm at 0 again. And it's going to follow that cycle all the way through if I want to keep drawing it, but I'm just going to draw one cycle there for the sake of time. Now I'm going to actually use an identity here to get this x written first. I'm going to factor out the negative 1 because it's an odd function and say this is the same thing as negative 5 sine of x minus pi. So we're going to have shifted pi units to the right here. Instead of 0, pi over 2, pi, 3 pi over 2, and 2 pi, we're now at pi, 3 pi over 2, 2 pi, 5 pi over 2, and 3 pi. And we're going to keep the same y values and then multiply them by negative 5. So 0 times negative 5 is 0. 1 times negative 5 is negative 5. This is a 0, this is a 5, and this is a 0. So at pi, we have a 0. At 3 pi over 2, we have negative 5. At 2 pi, we have a 0. At 5 pi over 2, we have a positive 5. 3 pi, we have a 0. And we could continue that pattern here if we would like. We get a curve that looks like so. That's our last one for the sine functions. We'll come back next time and we'll talk about some cosine functions.